Hello there, Mr. Sutton here with the BC Calculus 517 Extra Practice Number 1 Solutions on integration by parts. For this problem, I'm trying to integrate this product here. Since I've got things that are multiplying and I can't use simplifying or substitution, it's integration by parts for this one. So here's my parts formula, uv minus vdu inside an integral for that second part. For u, I have a choice between algebra and logs. Well, according to my acronym LATE, logs come before algebra when you're picking your u value. So I'm going to pick ln of x as my u value. And in general, I want to pick something for u that I would rather differentiate than integrate. I can take the derivative of ln of x. Taking the integral is kind of a pain, so we're going with u ln of x. And then for dv, I've got 4x to the 7th dx. du then is going to be 1 over x dx. And then for v, the antiderivative of this expression, this bumps up to an 8. Dividing by that, I've got 1/2 x to the 8th. All right, multiplying it together, I'm going to use my 7 little pattern here. So we've got uv, that's going to be 1/2 x to the 8th ln of x. And then v du, that's going to be, let's see here, this x is going to cancel with one of these x's. So this is 1/2 x to the 7th inside the integral. Taking the antiderivative out here, well, let me just rewrite this part first. And now the antiderivative here, this bumps up to an 8. Dividing by that, we've got 1 over 16 x to the 8th that we're subtracting. And don't forget the plus c. For this problem, I'm trying to find the antiderivative of x squared times sine of x. Since I can't really simplify or use substitution, and I've got the product of two functions, I'll try integration by parts. So I've got uv minus integral of v du. For my u value, I've got a choice between algebra and trig. A comes before t in LATE, my little helper acronym there. So I'm going to go with x squared for my u value. That means dv will have to be sine of x dx. So du then is 2x dx. And v, the antiderivative of sine, that's negative cosine of x. Multiplying straight across, I've got negative x squared cosine of x. So that's the first part of the 7 that I always draw when I multiply these. And then I've got minus the integral of, we've got negative cosine of x times 2x dx. But since we're already subtracting, those two negatives cancel. And I'm just doing plus 2x cosine of dx inside there. And at this point, we've got a choice here. Option number 1 is we can look at this integral and say, oh, this is another integration by parts problem. I'm going to do that again. Or we could look at the answer choices and notice that we actually already have this answer choice right here, which, by the way, that should have an x in the cosine function. There we go. Yep, we've already got that answer choice right up here, choice B. I mean, if they're just going to hand it to us, right, why work harder than we have to? For this problem, I'm trying to integrate this product. Since there's no way to really combine these or use substitution, it's integration by parts time. So I've got uv minus integral of v du. I'm going to pick out my u and my dv value to start with. So for u, I've got a choice between logs and algebraic stuff. LATE, L comes before A in my little acronym to help me decide. So I'm going to use a u value of ln of x. And the main reason, again, for this is I don't really want to integrate ln of x. I don't really know how to integrate it quickly. So I'd rather differentiate it. Let's let it be u. And then we've got dv. That's going to be, I'm going to rewrite this with a negative fractional exponent. So I've got x to the negative 7 over 3 dx. All right, let me go ahead now and differentiate ln of x. So my du in this formula is going to be 1 over x dx. My v value, the antiderivative of this is going to bump up to a negative 4/3. Multiplying by the reciprocal, I've got negative 3/4 times x to the negative 4/3. Multiplying now to get my formula filled in, I've got negative 3/4 x to the negative 4/3 ln of x. That's that whole uv part. And then this next part, I've got a negative, so I'm going to write positive, and then the x's are going to cancel a bit. This is going to be positive integral of 3/4 x to the negative 7/3 dx. and it's negative 7/3 now because you're essentially dividing x to the negative 4/3 by x to the 3/3. So we're subtracting 3/3 from negative 4/3 to get negative 7/3. All right, moving on. We're going to take our antiderivative for this expression now. So this bumps up to a negative 4/3 again, and I'm multiplying by the reciprocal of that, negative 3/4. That gives me minus 9 over 16 x to the negative 4/3. And I've still got this original stuff here, and I've got a plus c. For this problem, I want to take the antiderivative of this expression. There's no way to really simplify this or use substitution. We have a few inner functions here, but when I take derivatives, I'm not going to be able to cancel out the other function. So integration by parts it is. Here's my parts formula, uv minus integral of v du. For my u value, I've got a choice between algebra and exponentials, and I always choose algebra first in those situations. A before E in that late acronym, or the way you can think about it is I would much rather take the antiderivative of an exponential than an algebraic. So here's my u value, 7 minus 3x. dv then is this e to the negative 1/5 x dx. For my du, the derivative of 7 minus 3x, that's negative 3 dx, pretty painless. Over here, antiderivative is going to be e to the negative 1/5 x divided by my tail, so multiply by negative 5 for that expression. Plugging things in, multiplying these now. This is going to be a little bit of a mess because I have to distribute. So I've got negative 35 e to the negative 1/5 x. And then by negative 3x, that's going to be positive 15x e to the negative 1/5 x. So that was just uv right there, these two terms. For v du now, I'm going to go this way. So that's going to be the integral, I'm going to be subtracting, and then I've got a double negative inside, so that becomes a positive inside of 15 e to the negative 1/5 x dx. All right, let's clean this up a little bit. So I'm just going to rewrite these first two terms, and now I need the antiderivative of this. So this is going to be 15e to the negative 1/5 x times negative 5, the reciprocal of negative 1/5. So that's going to end up, and I've already got a negative out here, so that ends up being positive 75e to the negative 1/5 x. And we have a plus c that we don't want to forget about. Now, if you look closely, we've actually got like terms, and this almost never happens when you're doing one of these integration by parts problems, but this time it did. We have these two terms here and here that are e to the negative 1/5 x's. Negative 35 plus 75 gives me 40 e to the negative 1/5 x. This term here is not quite the same as this term because there's this miscellaneous x in here, but otherwise everything else is going to be the same. For this problem, I'm trying to integrate this product. I'm going to have to use integration by parts because I can't use substitution or simplifying or anything else really. So here's my parts formula, uv minus integral of v du. And for my u value, I have a choice between algebra and logs. I always go with logs in this situation, so ln of x. And I do that because ln, that's easier to take the derivative of that than to take the integral of it. So now I've got a dv value of, I'm going to write this as x to the 4/5 dx. My du value is going to be 1 over x dx, the derivative of this ln of x. For v, the antiderivative of dv, we have to, let's see, this bumps up to a 9/5, and we're multiplying by 5/9. So 5/9 x to the 9/5. Time to put it all in the formula now. So for uv, we've got this term times ln of x, minus, we have an integral of these two things, v and du multiplied together. X to the 9/5 over x is going to be x to the 4/5 again. So this is integral of 5/9 x to the 4/5 that we're subtracting. Taking the antiderivative of that integral now, we've got, let's see here, this bumps up to 9/5 again, so we're again multiplying by 5/9. That's going to be 25/81 x to the 9/5. So we rewrite our original expression, minus 25 over 81 x to the 9/5 plus c. For this problem, I've got a differentiable function f such that the integral of f times sine equals all this craziness. We want to know what f actually is. So essentially, I'm trying to figure out, I've got an integration by parts kind of set up here. In general, we have integral of u dv equals uv minus integral of v du. This is our integration by parts formula. We're basically trying to figure out either u or v. I'm not really sure which one f of x is supposed to be at this point, but we're going to get to the bottom of it. I'm just going to find all four different parts here, and then we'll figure it out from there. So, looking at my pattern, the easiest thing to pick out in this situation is going to be v, because it's the only thing that's actually repeated on the right side here. So I notice that cosine gets repeated twice, so that's got to be my v value, either positive cosine or negative cosine. I'm just going to write cosine is repeated for now, but now let's figure out if it is positive or negative. So we notice here that we have a negative out in front of this uv term here, and we've also got a positive integral, whereas the general form calls for a minus integral. So that suggests to me that cosine has to be negative. And my reasoning behind this, it really comes down to this whole f of x term. If f of x were a negative function, the negative would be built into whatever we get when we solve for f of x. They're not going to put another negative out in front of f of x just for kicks and giggles. So that tells me that this negative has to actually belong to the cosine of x. And that kind of fits with what's going on over here. We again have cosine of x and a positive here, so that the negative from cosine must have gotten used up out here. So I'm going to let my v value be cosine of x, negative cosine of x. And I'm going to go from there. If v is negative cosine of x, that means dv is going to be positive sine of x dx. And that matches what we have in the original function here, or the original integrand. We have a positive sine of x and a positive f of x. That means then if v is negative cosine of x over here in this expression, that means that this 4x cubed must be the du part actually. If we've already used up v on cosine, that means du must be 4x cubed based on that integral. Well, now I only need one thing, and that's the u value. I can figure that out, and I know my u value now is what I'm looking for, because negative cosine was used up, so this f of x must correspond to the u over here. So antiderivative of that is just going to be x to the fourth, which means f of x equals positive x to the fourth, which means we're going with answer choice E. And you kind of knew you were on the right track because they gave you a negative version of x to the fourth to mess with you. They didn't do that with anything else. So yeah, choice E. For this problem, I'm trying to figure out the definite integral from 1 to 9 of radical x ln of x. Since I can't combine or use substitution, I'm going to have to use integration by parts. Here's my formula for the definite integral using integration by parts. I need to pick out uv, du, and dv just like I always do. For my u value, I have a choice between algebraic and logarithmic. L comes before a in late, so I'm going to go with ln of x for my u value. And I don't want to have to integrate ln of x. So then dv is going to be radical x dx. And I'm going to write that as x to the 1/2 just to make it a little bit easier to take the antiderivative in a second here. But let me do du first. That's going to be 1 over x dx. And now for v, the antiderivative of this, this bumps up to 3/2, and that means I'm multiplying by 2/3. So 2/3 x to the 3/2. Now using my little 7 here, following the 7 to plug things in, we've got 2/3 x to the 3/2 times ln of x, evaluated from 1 to 9. And over here, I'm subtracting integral from 1 to 9 of, we're going to have, let's see, this x cancels with some of this, so 2/3 x to the 1/2, because you're essentially dividing this by x to the 2/2. Now I need to take my antiderivative for this thing, and I'm going to put it inside the evaluation box with the rest of this stuff. So I'm going to start by writing my box here, and I'm going to leave it open. My antiderivative for this bumps up to a 3/2, so I'm multiplying by 2/3 again. This is going to be minus 4/9 x to the 3/2. And all of that now is getting evaluated from 1 to 9. So I've got all this stuff with 9 plugged in. So this is 2/3 times the square root of 9 cubed times the ln of 9. And let's see, over here I've got 4/9 times, again, radical 9 cubed. From all that, I'm subtracting pretty much all this stuff with 1 plugged in. So square root of 1 cubed, 2/3 ln of 1, and same thing over here, but with a 1 plugged in. All right, so let me go through this now step by step, just to practice simplifying in case you ever see something like this on a multiple choice. So over here, square root of 9 is 3. Cube that, we have 27. 2/3 of 27 is 18, so this is 18 ln of 9. Here, we have essentially 4/9 times 27. That's going to be, let's see, 12, so minus 12. Over here, ln of 1 is 0, so that conveniently gets rid of all that. And this is just going to be 1 times 4/9. We've got minus 4/9, so positive 4/9. And now all I have to do is combine the negative 12 and the 4/9. Well, how many ninths is 12? 12 times 9 is 108. So this is negative 108 ninths plus 4/9, or negative 104 ninths to go with our 18 ln of 9. And that's as simplified as it can possibly get.